All right, everyone, we're going to get started. This is the second question. I am recording. And again, I'm hoping that this exercise, not only are you getting the hang of it, but your speed is increasing. You will see that we're going to do this again and again and again. So even if I don't give you that much time, know that there's a lot more of this to come. All right. That's probably not an exciting news for you, but let's go. Part A, domain. Again, typically, by now, you can see that X can belong to anything except for that one point or whatever that point that should not be in the denominator. And that would be a +5. That's going to help you with the vertical and horizontal asymptotes. Part B, X-intercept. In other words, when is the Y value going to equal a 0? Well, if f of X is equal to 4 over negative X plus 5 or 5 minus X, whatever, that will never be a 0 because the numerator will never be a 0. Therefore, no X-intercept. Just like before. Part C. Y-intercept. The Y-intercept is when the X value is equal to a 0. That is 4 divided by 0 plus 5. There's my Y-intercept. Sorry. Yes, my Y-intercept. Great. Let's keep going. Part B, vertical asymptote, AKA, take a look at the denominator. When will the denominator ever approach or equal a 0? Because when that equals a 0, as it approaches that, you know it's going to get really, really high or really, really low. Anyone? Very simple. Zach? Yeah, right? And I'm not going too much into why that makes sense because it's supposed to be part of grade 11. If you're still not sure how I'm relating these two together, I suggest you plug in, make X equal 4.999999, and then make X equal 5.00001, and tell me what those numbers are. And you will see it suddenly skyrockets like crazy, right? You should have established this relationship when you were investigating this in grade 11. That's why I'm not taking too much time. Question? So when X equals a 0, what's the Y value? Right, so that would be the Y-intercept. Like the X value is automatically a 0. Question? No? Okay. Yusuf, can't have that. So either you eat outside, which I totally welcome you to do, or what is, yeah. Just because 2 reasons. Number 1, science classroom. Number 2, COVID. Right? Makes sense? All right. Yeah. Science, think about it this way. Science classrooms are where we have most number of experiments, which will use the most number of chemicals, some of which could be airborne. Yeah. Get it? Make sense? Yeah. You can sort of like sprinkle on your air, okay, onto your food. Okay. Vertical asymptote, X is equal to a 5. Part E, horizontal asymptote. Again, you will see how to identify this differently at a later date. But for now, it is easiest to check what is the value that Y cannot equal. Y cannot equal a 0. So we're going to have a horizontal asymptote at Y equals a 0. F, don't worry about the range. You can sort of use this as your thing, but we haven't really done that. Don't worry too much. Describe the end behavior. Let's do end behavior. As X approaches infinity versus as X approaches negative infinity, what happens? Well, f of X will become 4 over negative infinity plus 5. But what's a plus 5 compared to infinity? Nothing. So this is going to be 4 over negative infinity, which is, if you plug in 4 divided by 1,000,000, you're going to see that it's close to a 0, but from the negative side of the asymptote. Pardon me? The equation comes with the negative. So what does that mean? Before, we always had positive infinity. We go to positive 0. It's upside down, exactly, because we have a vertical reflection. Everything should sort of come together. So negative infinity means 4 over a negative x, so negative infinity. That's a positive infinity. So this is approximately 0, but from the positive direction. As of right now, that's essentially all we need to do. You could test the behavior close to the vertical asymptote as well, but I'm just going to move on. We have x can't be equal to a 5, so it should be somewhere here. That's x equals a 5. That's where the vertical asymptote is. The y value, so the x-intercept is 0, 4 over 5. That's like a 4 over 5. Vertical asymptote is here. Horizontal asymptote, we still have one here. And as x approaches a positive infinity, it's going to be at the negative side of the asymptote. As x approaches negative infinity, we'll have the positive side of the asymptote, which agrees with my y-intercept. My y-intercept is in the positive side. So I can safely say it's probably going to pass through and go upwards, teleport this way, and continue like that. There it is. Any questions? Oh, well, I'll try to keep this brief. Okay. Everyone, as you're collecting this, part of you will read it because it seems like a very large package. However, everything that we have done for this is a repeat. Okay, so for people who are joining, we're moving on to 3.2. Question 3.2. Are all the functions of these type going to be in the form? No. Well, Eli, up until now, yes. But as you can see, if you look at the title of the next one, it says reciprocal of a quadratic function. Know that every single thing we have done, vertical asymptote, horizontal asymptote, and behaviors, all of that is going to just be repeated, but with a different function. So the reason I spent so much time on a grade 11 review was just so that you get used to the steps. Let me explain. If you take a look at the sheet, so as I have, so let me clear this. 3.2 is where we're at now. I'm going to try to draw this quickly so we don't spend too much time. Yeah, this is the one where I wanted to use a document camera. You know what? I think I'm going to. Stop sharing with the doc camera. Video this. All right. Can everyone see this? That's okay, right? I hope. All right, so this sheet, I am going to try to sketch all of this out after we do the characteristics this time. So I'm going to reverse. Here we go. Here's a quadratic with the x values, or in factored form. What are the zeros? Quickly. Go ahead. Yeah. And by parallel then, what are the values that we cannot have? What is the vertical asymptote of my reciprocal? There you go. Vertical asymptote at 5 and -3. Is that better? It's clear enough, right? Okay, domain. And domain here, I think it's, again, same thing, but now this might be a little bit packed, but again, intervals when the function is positive, intervals when the function is negative. These two and these two, if you look at your previous sheet, are they going to be the same or are they going to be different? Same. Let's do it. I'm going to quickly sketch this function just to give you an idea of what it looks like. This is a 5, that's a -3, and we have a parabola. When is this section positive? Here and here. So I'm going to write it out as it will be positive from -∞ to a -3, and just because it's positive, we're not making it equal to a 0. So in 5, infinity. And because I know they are going to be the same, there. And I'm hoping this is a red. I am, oh, that's gross. Okay, that's, I'll use an orange. And the flip side, that section is going to be negative. So -3 to 5 will be on the negative side of my function. Same with this.
When you say we got something like that, it's easier to just like isolate one and just like look at the actual quadratic function.
For now, you will see we can use the techniques we've learned in 3.1 to analyze a reciprocal. You will see how we can use the same stuff. But I wanted to show you that you can approach it from a variety of different angles. So the first thing I'm going to do is show you how there is a parallel, just like we did for reciprocal linear. If you remember in the beginning of the lesson, I showed you a parallel between these two, right? X and 1/x. It's the exact same pattern here. Next, at what point is this curve increasing? Anyone? Where's a vertex in between? Joseph?
Well, I don't know exactly, but the actual symmetry is one.
It's 1. That's where the vertex is going to be. Like,
I don't know that.
you're correct. So the interval that it's increasing is from the vertex to the right. And it's going to be from 1 to infinity. And then where is it decreasing? All the way up to the vertex, which is -∞ to 1. And you will see, just like before, that they are going to crisscross. So let me draw a little thing here. I'm going to put a highlight around this part to show that they are identical. Then I'm going to highlight this part with this part to show these two are identical. And then is that a red? Oh, I'll use a red. Okay, green. I'll get it later. Okay, next, Y-intercept. If we plugged in a 0 here, it's -5 times a 3. The Y-intercept is going to be 0, -15. I plug in a 0. I plug in a 0, right? Horizontal asymptote. Does a parabola have a horizontal asymptote? No, right? And behavior? Well, it's a little hard to say. It just goes to infinity, and then on the negative side, it goes to infinity, right? Let's do this, okay? Let's write that just so we fill this chart. Yes. Sure. That communicates the same thing. Absolutely. That's a pretty efficient way. You can say this is quad 2 goes to quad 1. So that would be quad 2 that goes to linears. I'm going to also go ahead and use a different color. -3, 1, 2, 3, 4, 5. And the Y-intercept is -15. -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way down to -15, all the way down there somewhere. I'm going to try to graph this as best I can. Right? Okay. Now we're going to move on and start working on the vertical asymptotes and all that jazz of the next one. Let's do the easy one. Y-intercept. When x is a 0, what is this equal to? 1 over -15. And you should have been able to guess that just from looking at this. Horizontal asymptote. Is there a value that the y cannot equal? 0.
So again, just to make sure, when the numerator is 1.
Well, yes, because that fraction cannot equal a 0. Yeah. So I have vertical asymptotes from our 3.1. We know that they are going to be vertical asymptotes. We've established the y-intercept and we've established the horizontal asymptote. Let's take a look at end behaviors. As x approaches positive infinity, that is essentially 1 over infinity times an infinity. It's basically 1 over infinity, right? Well, infinity squared, like, yeah, it's going to be a big number. In other words, y is going to approach where g of x is going to approach 0, but from the positive direction. And if x approaches negative infinity, that's negative infinity times a negative infinity. It's going to be positive. Why? The g of x is still going to approach 0 from the positive direction. Because I have two x's. Negative infinity times a negative. I don't know what those numbers are, but I do know they're both negative. So it's got to be a positive fraction. Okay, so I'm going to zoom out a little bit so you can see the entire graph. And watch me put this together, okay? Number one, instead of vertical asymptotes, I know that, instead of X-intercepts, I know that they are asymptotes. It's gonna be, yeah, it's gonna be something interesting, right? Okay. Yes, yes. Okay, so we've got vertical. I've done that. And I've established this. This is gonna help me confirm whether I got this graph right or not. And this part, knowing that they're gonna switch, you will see that the pattern still sticks. My y-intercept is 0, negative 1/15. So it's gonna be really close to, let's see, 0 and negative. That's my y-intercept, really, really close to 0. My horizontal asymptote exists at y equals 0. Yes, I know this is a horizontal asymptote, but you're going to see it cross. Oh, wait, maybe you won't see it cross. Anyways, never mind. Next, the end behavior. As x approaches infinity, I'm on the positive side of this axis. Does anyone have not blue or orange or yellow? Maybe you have a green or something? Okay, I'll use red then. Okay. If you don't have a highlighter, then it just doesn't show up very well. So I know that it's going to be above horizontal asymptote. As x approaches negative infinity, I know it's going to be above as well. It has to be positive. So like, huh? I have to get here. But I can't, what, right? What could help me? Check the behavior near the vertical asymptote. Check it.
Are we gonna do like 2.99?
Sure. Just, you know what? You don't have to even do 2.99. Try 2.9. Try negative 2.9 and negative 2.9. Tell me what value you get. Just tell me if it's a positive or a negative. Well, I don't know where, I know I have to start here. I have to cross this dot. Tell me where I'm supposed to go. Like, I can't cross this dotted line and I can't cross this dotted line. So I think. So if you plugged in, if x equals what? If x equals negative 2.9, my y value is? No, it can't be negative. Wait, is it negative? Oh, yes, you're right. You're right. There's a positive. Negative 1.26. So it's a negative number. So if it's negative 2.9, I am here. If it's a negative 2.9, I have a negative number. You get it? Forget that. Try this. Can you try x equals 3.1, negative 3.1? 1.26. It's a negative. One 1.2. It's a positive. So if I'm to the left of this vertical asymptote, I have a positive number somewhere here. If I am to the right of the vertical asymptote, I have a negative y value. I'll say it one more time. If I plugged in an X value of negative 3.1, I get a positive number up here. I get a positive number. If I plugged in a negative to the right of the vertical asymptote, I get a negative number. So my line has to start here and end off on a positive number. My line has to then teleport to the bottom. The curve is going to look like that. That's the only way I can satisfy this discovery. I'll say it one more time. I was here and I didn't know where to go. So I tested a number really close to the vertical asymptote just to see what direction I must go. When I plugged in a negative 3.1, which is right here, it told me I'm going in the positive direction. If I plugged in a number to the right of the vertical asymptote, it told me that I teleported beneath the the x-axis. Yes, Rowan?
In order to get the, you need like one of the, that's what we make it.
Okay. And then again, from here, am I crossing the axis? Maybe. But what happens when I get close to this vertical asymptote?
Yeah, I plugged in 4.9 and it's negative 1.
Okay, so you're already getting the hang of it. So if x equals 4.9, my y value is negative
1.26.
negative 1.26. And if I plugged in 5.1,
We're probably gonna get
probably about a 1.2. So if I am to the left, 4.9, right? If I'm to the left of the vertical asymptote, I have to get a negative number. If I'm to the right of the vertical asymptote, I get a positive number. And then I have to finish here. So the only way I can get there is if I do that. So introducing graphs of reciprocal functions. What you are learning here is what happens when you have a bunch of restrictions, specifically in the denominator, right? And so take a look. I'm not done. Take a look at this red curve. Where am I increasing? Am I increasing? Yes or no? Yes, 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 yes. And then jump. Am I increasing? Yes. And then decrease, 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 jump, decrease, decrease, decrease. So from negative infinity to the maximum, right? To a 1. I am testing to see what the behavior was close to the into the equation. Yep, 5.1 minus 5, 5.1 plus 3. So I am increasing from negative infinity all the way to 1. Huh. And then where am I decreasing? From 1 all the way to positive infinity. Huh. Yes, Joseph, I know. I was just trying to simplify for everyone. Right? A couple of reasons, but essentially, do you remember the minimum? So no, let me reiterate. The minimum of a regular quadratic was at 1. When you flip it, you will find that it is exactly in the center as well. Just like how.
I know why.
No, it's at 1. Yeah. So take a look. This is where I get the 1. Everyone, please take a look at your previous sheet. Number 6 says the local maximum of F becomes the local minimum of G and vice versa. So if your maximum of your quadratic was at 1, right here, my minimum was at 1, my maximum will be at 1 as well. Okay. I want you to know that it might seem complicated, but the process is exactly the same. We're going to check for asymptotes, end behaviors, and graph. I'm going to do one more example, and then I'm going to let you cool your heads. You can do some examples for homework, but I ruined this paper, so I'm going to need another one. Let's do this first example together. And then once you get the hang of it, I hope that you will feel comfortable trying this on your own. Great. Yes. Okay. If you want to find X-intercepts or vertical asymptotes, you need it in factored form. I'm going to do that for you. There. What's the domain? X can't be a 6. Part B, calculate the intercepts. Let's do the easy one first. What is the y-intercept when x equals 0? That is -4 over -6 times -6. That is 1 over 9. -1 over 9. Next. What is the one value that this cannot be? Will f of x ever equal a 0? No. You see that from your fraction. Therefore, no x-intercepts. Yes. Pardon me? Yes. When you're calculating the y-intercept, y is the 4 negative. Okay. Okay, part C. From I think I got a question. 1 second. Vx is what? Okay. I see you're participating. Thank you. Oh, I do not want to close chat. That's our there. Okay. Which is positive 36. And then negative comes with the equation. No, keep correcting me, please. You never know if my brain is crazy. Okay. So I appreciate it. Part C, asymptotes. Using what we established in A and B, you have a good idea of what the asymptotes might be. Vertical asymptote is when x is equal to 6, because that's when the denominator equals 0. Horizontal asymptotes, I do know that the x or the f of x cannot equal a 0. Therefore, I have a horizontal asymptote there. It's going to get closer and closer to 0, but it'll never equal a 0. No. Remember, y-intercept means the x value equals a 0, and I plug that in. Also, no, part B, we're doing both intercepts at once, just because we just get it done in one shot. I see what you're saying. Okay, part D. Let's get a new piece of paper. Part D. It asks for n behavior. So I'm going to check as x approaches infinity and x approaches negative infinity. F of x is going to be -4 over infinity, which is going to be essentially 0 from the negative direction. And f of x is going to be -4 over negative infinity, which is going to be a positive. Oh, wait, yeah, negative infinity times negative infinity is a positive. That's a plus, which means that's a negative. Correct. Part E. I wrote this as new, but we did it already in the previous example. Let's confirm the behavior near the vertical asymptotes. So the vertical asymptote is at 6. So you can plug in like a 6.01 or a 5.99. Yes, yes. Because you have a negative value times a negative value, the denominator will be a positive. It's like -1 million times -1 million will be a positive, and then there's a negative there.
Why is it positive? For, that's like when x goes to negative.
No. So it's the same question. If you plugged in a -1 million here and a -1 million here, you are multiplying by 2 negatives, which gives a denominator as a positive, and then you multiply with the negative again. Is that? Well, remember, x is approaching negative infinity. So take x as -1 million. What is -1 million minus 6? Multiplied by -1 million minus 6. It's going to be two gigantic negative numbers multiplying with each other. So what's the result? It's a positive. Does that make sense? Try -100. What's -100 times -100? Positive. Why can't I use? I try that here. If I plugged in a positive number times a positive number, I get a positive denominator. Multiply that with a negative that's already a part of the function, and you'll get a negative number. Albeit it's really small. That's why we say 0, but coming from the negative side. Let's try this again. N behavior close to the 6. It's going to be -4 divided by 0.0001. I just did that in my head. That's going to be a negative number. That's all I need to know. It's on the negative side. And x, if it was a 5.99, f of x is going to be -4 over a negative times a negative. That's going to be a positive 0.0001, which is still going to be a negative number. Okay. With this information, let's see what the graph gives us. Yes, negative. Sorry. Negative. All right. Here we go. You have the information in front of you, so I'm going to zoom in on my graph. I have asymptotes at 6 and 0. Okay, my Y-intercept is negative somewhere here. My end behavior, as I approach positive infinity, I'm going to be underneath the 0. At negative infinity, I'm also going to be under 0. Interesting. Just to confirm, I'm not doing anything stupid. Right? Okay. And then, what's that? When I get close to the vertical asymptote, what did I end up with? A negative value. So it's going to be somewhere here. And then when I'm to the right side, and when I'm to the right side of my vertical asymptote, where am I coming from? A negative value. So I'm going to be coming from here. Is this enough information for you to connect the lines?
Yes, of course.
Yeah. And so we have something like this, and then something like that. That is the only way we can satisfy all the clues that we've discovered. And please note, if this was a regular term school, and if you were taking calculus, you would be doing this exact same exercise with calculus. And that's why they call it a co-requisite, because you are doing the same thing for 2 classes at a time. So you have that much more time to practice it. Unfortunately, because of the situation we are in, you're only doing this for 1 class. But know that if you are taking calculus, you're doing double the work now so that your calculus class becomes easier. Okay? So don't think of it as a waste of time if you're going in that direction. Just work really hard and practice. The remaining sheet I have. So there's 2 more examples on this piece of paper, but I'd like you to try this for homework. See what graphs you get. What I'm going to do tomorrow is I'm going to walk in with the answers to these examples drawn out. So you can graph your graph as best as you can, and then you look at my picture and you will know if you did this graph correctly or not. Okay, that is your homework. I know time is really tight, but thank you for your, your attention until now. You can relax. And I'm going to close this. I'm going to stop this recording.